The NeuroDOT RenderTool allows visualization of surface maps, including maps generated using NeuroDOT, as well as other imaging software such as SPM or FSL. The tool offers convenient interactive control of render settings, such as color scaling, color map selection, view orientation, and cortical inflation. A rendered image can be saved in a variety of file formats, allowing results to be included in a presentation or loaded into editing software for manuscript preparation. Additionally, render settings can be saved for later use in scripted processing. In this video, we describe use of the render tool, including data selection, display options, and the editing features available in the render window. Currently, only a MATLAB implementation of the app is available. A Python port, as well as tools for creating interactive slice renderings, will be added in a future release of NeuroDOT. Open Render Tool by double-clicking the application icon located in the NeuroDOT installation, or by typing the name of the app in the MATLAB command window. On startup, the Render Tool displays the main control window, organized into sections for file selection, graphical settings, and general options. To begin a render, load an overlay file using the Select New button. The overlay can be in Nifty, 4DFP, or NeuroDOT native MAT file format. Both 3D and 4D multi-frame data are supported. Loading a 4D overlay will result in a frame selection widget being added to the control window. You may also select the cortical mesh used to render the overlay. The default mesh includes 3 levels of inflation and is normalized to MNI space. After the data is loaded, the tool will open a graphics window and render the overlay using the current settings. You may now adjust the results using the controls provided in the Render Tool main window. The first group of controls affects color scaling. The color scale defines the overlay value, which is mapped to the maximum entry in the current color map. Large-scale values expand the color range and result in lower image contrast. Smaller values compress the range, which can result in image hotspots. Optimal scale selection is typically a process of trial and error. The color scale may be set using either the slider or the slider text box. If a value is entered that exceeds the current maximum of the slider, it will define a new maximum value, increasing the range of the color scale. Two scale modes are provided. In absolute scaling, the scale value is applied as entered. In proportional scaling, the scale value is interpreted as a proportion of the maximum value present in the overlay. The color scale mode is selected using the radio buttons under the color scale slider. When rendering a 4D overlay using proportional scaling, a new scale factor will be applied to each frame. Small magnitude overlay values may be omitted from the rendered image using thresholding. A negative or positive threshold is set using the threshold sliders, or by entering a value in the text box beneath the slider. The values are interpreted as a percent of the full extent of the current color scale. Only values less than the negative threshold or greater than the positive threshold will be included in the rendered image. The threshold values are indicated in the color bar if one is currently displayed. The second group of controls in the main window implement general display options. The color bar menu allows you to toggle display of the color bar on and off. The current color map can be changed using the color map menu. The display orientation can be changed using the view menu, which includes lateral, dorsal, and posterior views. The degree of cortical inflation can be selected using the inflation pull-down menu. This menu will not be available if the loaded cortical mesh file does not define inflated meshes. The current overlay interpolation is selected using the interpolation menu and includes a choice of linear or nearest neighbor interpolation. Finally, you may choose to display only positive values in the overlay by using the checkbox at the bottom of the control group. Note that the current color scaling will be updated after selecting this option. A general control group is found at the bottom of the main Render Tool window. You may print the current render settings to the command window using the indicated button. These values can be copied for later use in scripted rendering, such as processing a collection of overlays after optimal settings have been identified interactively. The Restore Defaults button will return all controls to their startup settings and re-render the image. The Help button will open a new window and display Render Tool help text in a scrollable dialog box. Close the Help window by selecting the Close button. Finally, to quit the Render tool, click the Quit button. This will close all open Render tool windows, including the Control, Render, and Help display, if open. Note the graphics window includes the default collection of MATLAB figure menus. These provide options for figure annotation, view selection, and general MATLAB control. Additionally, the current window contents can be saved using the Save option found under the File menu, or copied to the clipboard as a bitmap image using Copy Figure in the Edit menu. A full description of figure menus can be found in the MATLAB documentation. Additional information may be found in the resources listed here. Feel free to contact the development team with questions or post them in the comments section below. Thank you for your interest in NeuroDOT.